Right, so we're doing simplifying radical expressions and multiplying radical expressions today. Actually, these are the two SOLs that cover that. There's actually some part of this which is dividing, but I'm going to push that to the next class. Okay. We'll do dividing and adding in the next class. So when you simplify a radical expression, right, the thing that makes it a radical expression is two things, right? First, it's got a radical symbol, right? And two, usually it's got a variable expression of some kind inside the radical. So we're trying to figure out, well, how do we simplify that kind of thing? Right? How would we simplify the square root of x squared? No. What's the square root of a square? It's just x. Oops. Right? If you take the square root of something that's squared, those two things undo each other. Right? You just get what's inside. Just like if I say, what's the third root of x to the third? That's x. And the fourth root of x to the fourth is just x, right? That's the starting point. Okay, but what if you've got more x's than just 2? Like if I'm taking the square root of x to the third, then, it's a square root and it's a perfect square inside. So how are we going to simplify that? Say again? No, there is no place for the calculator in any of this. So if you're sitting there clicking on your calculator, you know you're going down the wrong path. Right? So you got to think, this is using a little bit of our properties of exponents, right? We're going to split this up into 3 is not an even number, right? But think of what's the next highest number less than 3 that's an even number? 2. So let's write this as x squared times x. Is x squared times x to the third? Properties of exponents say you add the exponent. Yes, it is. So now when we take the square root of both of those, right? The square root of x squared gives us the x, right? And then there's a square root of x. There's one x that's left inside that you can't take out. Right? You take out everything you can, and then you'll end up leaving something behind. That happens some of the time. Right? Same thing here, right? This x to the, well, let me just say it like this, okay? The way I think of this, and you can see it, people work this out in a slightly different way. But if you want to know how many x's you take outside of the radical, you divide, right, this power by what we call the index, right? 3 divided by 3 is 1. Right? 4 divided by 4 is 1. Right? Over here, we don't see a 2, but it's an implied 2 right here, right? So 2 divided by 2 makes 1. So you're always looking to divide by the index and see. If you can take everything out, by all means, you take everything out. Right? In this case, when I did the 3 divided by 2, I didn't get a whole number. Right? It doesn't go evenly. So I said, okay, let me break it up. Let me break it up into the most x's that I can simplify and do it. Like this one here, if I try to do the 5 divided by 3, right, that doesn't go. So you say, okay, well, what's the next lower number than 5, which is divisible by 3? What's the first number less than 5 that's divisible by 3? 3. So make this x to the third times x squared. Right? By the properties of exponents, that's the same thing, right? X to the fifth is x to the third times x squared. And now, if I take the third root of both of those, right? The third root of x to the third is x, right? That one goes. 3 divided by 3, there's your x. Right? And then the third root of x squared can't be simplified. Right? Because the power that's inside is less than the index itself. There's no way to break it up into any smaller parts that we would be able to simplify some. So when you see something like this, you know you're going to take part of it out and part of it will stay inside. How about this one here? Can I take all the x's out? How many x's can I take out of there? I'll be able to take out 4, and how many will be left behind? 3, right? So if it helps to see it this way, you say 7 divided by 4. That doesn't go, right? So what's the first number less than 7, which is divisible by 4? 4. X to the 4th times x to the 3rd. Okay, now the 4th root of x to the 4th times the 4th root of x to the 3rd, right? The 4th root of x to the 4th is x. And the 4th root of x to the 3rd cannot be simplified. You're done. Good. Okay, now most of the time, you're not just going to have one variable underneath, or it's not just going to be necessarily variables. It's going to be some combination of numbers and variables that's inside, and you're going to have to address each one individually. Like in this one here, right, that's going to be the square root of 49 times the square root of x to the 5th. Right, the square root of 49, we know. Right, that's going to be 7. Right, now the square root of x to the 5th, will I be able to take all the x's out? I mean, 5 divided by 2, does it go evenly? No. So what's the next lower number than 5, which is divisible by 2? 4. So let's break this up into a x to the 4th times x. Right. So this will be the 4th root of x to the 4th times, the square root of x to the 4th and the square root of x. Right. So this is, let's see, 7. How many x's do I take out of the square root of x to the 4th? Remember, there's a 2 there. 4 divided by 2 is 2. Right? 2 come out. And then the square root of x can't be simplified. All right, the next one has numbers and 2 variables going on, and this time it's a cubed root. Right? So we have the cubed root of 125 times the cubed root of x to the 9th times the cubed root of y to the 4th. All right, now, can you take the cubed root of 125? I mean, you ask yourself the question, is 125 a perfect cube? Yes. 5 times 5 times 5. Again, if you don't know your perfect cubes, then make a table of them or something and look at them, right? Go to in your calculator. There. Right, you can do, in fact, let's say you're really not strong on your squares or your cubes, right? Then on the first line in the calculator, put x squared, and on the next line, we'll put x to the 3rd. And then on the table of values, you could see these are all the perfect squares, these are all the perfect cubes. So again, look down at do you find in the perfect cube aisle, you see the 125? So yeah, 125 is a perfect cube, 5 cubed is 125. Right. So we're going to definitely be able to take a 5 out of this. How about the x to the 9th? Can you get all the x's out of that? The 3rd root of x to the 9th? 9 divided by 3? It goes, right? So that's x to the 3rd. And then how about the third root of y to the fourth? Right, 4 does not divide evenly by 3, right? So you break it up into a y to the third times y. Right? Make this y to the third times y. And then you can do the third root of y to the third root of y. So the final answer is 5x to the third. How many y's come out of that? It's 3 inside, which means it's 1 outside, right? 3 divided by 3, y. And the third root of y. So that's, I think they've got one more for just simplifying, just plain simplifying. Before we start multiplying, we're going to simplify. Right, try to do that one. And first, no, actually I'm going to do this one, and then you do one. So this is going to be the third root of 54 times the third root of x to the fifth. So first, for the 54, you ask yourself, is 54 a perfect cube? So if you're not sure, you look at your table of values. Come on. There we go. You know, you look in the perfect cubes here, right? 1, 8, 27, 64, jumped right over 54. Not a perfect cube. So the next question is, does 54 have any factors that are perfect cubes? Right? So what if you start dividing from the highest number, which is less than 54, and see whether it divides evenly? What is 54 divided by 27? It's 2. It divides evenly. So actually, 54 is 27 times 2. So by breaking up the 27, or the 54, we will be able to simplify part of it. Right? This is the, let's make this a 27 times 2. Right? Because 27 is a perfect cube. And this x to the fifth, right, will we be able to take out all of the x's? It's the third root of x to the fifth. 5 divided by 3 does not go evenly. So what two x terms should I have, x factors? It'll be x to the third times x squared. Right? That less than 5, the highest number which is divisible by 3 is 3. So you break it up in x to the third, x squared. Right? So now we take the cube root of all of these things. Right, the cubed root of 27 is 3. The cubed root of 2 cannot be simplified. Right? The cubed root of x to the third. X, 3 divided by 3, there's 1 x that comes out of that. And then the third root of x squared. Right? And then last step, put together everything that's outside the radical, 3x, and put together everything that's inside radicals into one radical, the third root of 2x squared. Okay. Okay. So try the same thing with this one. And again, if you look at your perfect cubes. And you're going to see that 128 is not a perfect cube, right? It's not in this list. So you want to start dividing by the numbers less than that. See whether any of these numbers are factors. So you could split it up into at least one part of that, which could be simplified. You know, and these numbers are usually chosen because, you know what, they will simplify some. You just pick the right number. And if you have trouble with the 128, move on to the x to the 7th and see whether you could figure out how much of that's going to simplify. Figure out, Sean? What'd you get? Not quite, because let's see, you did that part right, and then here, what's the next lower number than 7, which is divisible by 3? You could have made it a 6, right? And there's a little more simplifying to do. But basically, now, it's almost right, which is here, because x to the 7, 7 divided by 3 doesn't go evenly. What's the next lower number, which is divisible by 3? 6. It should have been an x to the 6 times x. What was the factor? What was the perfect cube that was the factor of 128? Should have been 64, right? I mean, it's the first one probably you would try. 128 divided by 64 is 2. Right? You start at the top and go down because you want the biggest factor, not just the first one you find. If you happen to go from the lower numbers first, you would have found 8, right? And that wouldn't have been correct. So let's see. We're going to write this like the third root of 128 times the third root of x to the 7th. And that is 64 times 2. You know, when I write these, especially if it's not a square root, if it's a cubed root, and I know I got to write that little 3 in the hook, I'm trying to write enough space in between these numbers that I'll be able to fit around it a radical, right? And then this x to the 7th, again, 7 divided by 3 doesn't go. But what's the biggest number that's less than 7, which is divisible by 3? 6. So it should have been x to the 6th times x. And now we can go third roots of all of that. Right? The third root of 64 is 4. So we have 4 times the third root of 2. The third root of x to the 6th. 6 divided by 3, 2, right? And the third root of x can't be simplified. All right, then put together everything that's outside the radical, 4x squared. Put together everything that's inside the radical, that would give us the third root of 2x. Done. Now, something that, to me, it's a little bit crazy the way this is presented, because what are we doing here? We're taking a radical and we're breaking it up into smaller radicals, right? We're saying, okay, I can factor 128x to the 7th into 128 times x to the 7th, so let's do 2 radicals, right? But after we do this simplifying here, the next thing we do is something they're going to call a product property, right? And the product property says that the product of radicals equals 1 radical of the product. But that's kind of what we had to know to do what we were doing before anyways. So maybe it could be presented in a better order. This one should have been a 3. So what this property says is if I'm multiplying radicals, as long as they're the same kind of radical, right, they're both square roots, then I can actually make that 1 radical and multiply inside that 1 radical 2 times 8. Right? And 2 times 8 is 16. So it's the square root of 16. I can simplify. That's a 4. Now, I couldn't do anything with the square root of 2 and the square root of 8, but by putting them into 1 radical, now I could get some simplification. So that's where we use product property. How would I use the same property on the second line? What would that equal? The third root of 2 times 32, right? Which is the third root of 64, which we've actually done a few times today, so we know that's a 4. So multiplying radicals, you just throw everything together, simplify like we've already simplified. Multiply and simplify. Okay, so try to do the same thing with that. What you get? Don't turn into decimals. No, we don't want decimals. We simplify square roots as much as we can. You should be getting the square root of 24. Is 24 a perfect square? Does it have any factors that are perfect squares? Check. It does. Again, right, here's the perfect square column, right? 24 is not in there. So start dividing. 24 divided by 16 doesn't go. 24 divided by 9 doesn't go. 24 divided by 4 that's a factor. Break it into 4 times 6. Any questions on that one? These are taken from the even numbers of the homework. It's about the same difficulty as the homework. Right? I found that their examples, they had some really complicated examples that if we just get lost in the weeds, this is more like what the homework is. Now there's one more example to look at because again, there's a homework problem that's kind of similar to it and it always causes a little bit of question, right? And that is, besides the radicals, you've also got some numbers, let's say coefficients, in front of the radicals. So the question is always, well, what am I going to do about that? So what do you do about that? You multiply them. They stay outside the radical and you multiply them. Right? So this times this gives us 6. Right? And then we have a radical, which is 5y to the third times 50y to the fourth. So just, if you've got coefficients in front of the radicals, just carry them along. They'll be there. They'll be part of the solution at the end. Okay, now this one, I got to multiply, so this will be 6 times the third root, all right, 6 times the third root of 5 times 50, 250, times how many y's? Y to the third times y to the fourth is 7. Add exponents. Okay, so that's what we need to simplify. Again, we're going to look in our calculator to see whether or not 250 happens to be a perfect cube, right? So let's see. It goes from 125, 216, 343. No, jumps right over 250. Okay, is it divisible by any of these perfect cubes, right? Start with, see, less than 250. You could go 250 divided by 216. That's not going to go. How about 250 divided by 125? That's 2. So yes, you could break it up into 125 times 2. Okay. How about the y's? Can I take out all the y's? 7 divided by 3, does that go evenly? So what's the next lowest number from 7, which is divisible by 3? 6. So break it up into a y to the 6th times y. Right. So now we're going to take the third root of all of these things, and we still have the 6, which is in front. The third root of 125 is, remember we just split it up for a reason, right? 5. 6 times 5 times the third root of 2. How many y's can I take out of that? The third root of y to the 6th? 6 divided by 3 makes 2. Okay. and the third root of y. Okay, now you put together everything which is outside the radical. 6 times 5 is 30, so 30y squared. Put together everything that's inside the radical, the third root of 2y. Okay, that is the lesson. So today we simplified and we multiplied. We're going to save the divide part until next time. And the homework, we're going to go back and do some more of those properties of exponents, 6 from that page. And then these are simplify and multiply and simplify. 3 problems, 3 problems.